Hi guys, I'm back with another example of that truth table enumeration algorithm that we studied in the previous video. I want to get another crack at it just in case, the previous example wasn't clear enough. So let us say that our agent starts off in square 1, 1, because that's the starting square, and its perception list is empty, right? Its sensors don't perceive anything. So that would mean, we're okay in square 1, 1, and it would also mean that square 1, 2 is okay, and also that square 2, 1 is okay. Because remember, if you have a stench or, breeze, if your sensors pick that up, then there must be a wumpus or a pit in an adjacent square, okay? So the AI decides, flips a coin, right, and decides to move to square 2, 1, okay? So it moves to square 2, 1, and again, the percepts list is empty. So similarly means, hey, we didn't detect a stench, no breeze, so the square to the north is safe, and the square to the east is safe. So the AI flips a coin, decides it's going to move to square 3, 1. So the agent ends up in square 3, 1. And it's in square 3, 1 that the sensors pick up a stench. Now, at that point, we've passed through square, 2, 1, right, on our way to square 3, 1. And there was, as we passed through there, we know that there was no wumpus in square 2, 1. We passed through that square and didn't die, right? But we also know that we have a stench in square 3, 1. Okay? Now, by the rules of the game, you have a stench in a square if and only if there's a wumpus in any of the adjacent squares. So what are the adjacent squares to square 3, 1? Well, square 2, 1 is adjacent. Okay? So there would have to be a wumpus in that square, or another adjacent square is to the north, which is square 3, 2. Okay? Or another adjacent square is 4, 1. Right? So now that means that possible wumpus there, possible wumpus there, possible wumpus there. Okay? So we might want to ask the question, safe for me to go into square 3, 2. So it's going to ask the question, is there no wumpus in 3, 2? If there isn't, then the AI can move there safely. So this is a sentence alpha, and I want to know if my knowledge base, with these two items, entails that sentence. Okay, so to answer that question, we rely on that truth table enumeration algorithm. Okay, so what that's going to do is it's going to build a truth table, and each row in that truth table represents one model of the world, one possible world, okay, within the context of this wumpus world problem that we've set up. Okay, so what are the variables here that need truth values assigned to them? Okay, well, we've got 3 possible places that the wumpus world could be in, assuming that it's true that there's a stench in 3, 1. So we don't know. We have to figure out where the wumpus could be and if it's safe to move into one of the squares. So one of those variables was square 2, 1. Another one of those variables was square 3, 2. And another one of those variables was square 4, 1. Okay, so those are the 3 variables that we're interested in right here. Okay, now, depending on the configuration of those variables, that's going to impact what happens with our knowledge base. Okay, so just for bookkeeping's sake, I'll go ahead and I'll add the W21 and the W, oops, and the OR W32 and the OR W41, just to help me keep stuff in straight in my head. Okay, you'll see why here in a second. Right. So anyway, so what we have to do is we also have to evaluate, some of these items in our knowledge base. Okay, R1, R2. Okay, and then we're going to have to evaluate whether or not our knowledge base is true. Okay, so of all of the true knowledge bases that we go through, or that could be possible, we're going to have to make some judgments. Okay, we're going to have to make some inferences. So we'll only examine those rows where the knowledge base is true. Now, the knowledge base will only be true if everything listed in the knowledge base is true. Okay. All right. So let's see how this breaks down. Now, there are two queued possible configurations for the wumpuses, right? So there's either a wumpus in 2.1 or there's not. There's either a wumpus in 3.2 or there's not. There's either a wumpus in 4.1 or there's not, right? So this first row is the first model. So let us assume that there's no wumpuses in any of them, right? Then that would make this sentence here false, because all the items are false. So wars, if everything's false, the whole thing is false. Now, how does that cause R1, this sentence in our knowledge base, to evaluate? Well, that would cause W21, not WT1, to be true, because false for WT1, not false is true. So what this is saying is no wumpus in 2.1, right? Now, one of our rules was one of our pieces of knowledge in our knowledge base was that we knew there was no wumpus in 2.1 because we passed through it. So that's good, right? So that's satisfied. Okay, now let's look at R2. There's a wumpus in any nearby square where there is a stench, right? So now if you look at what this evaluated to false, right? But we know that the stench is true because our agent perceived it. Now take a look at the truth table. True if and only if false, right? So this would be our P in this case, and this would be our Q. If you take a look, true if and only if false, the whole thing evaluates to false. So we can put an F there for false. Since they weren't both true, that means that this particular knowledge base the knowledge base is false in this model, okay? Because both of these entries in the knowledge base have to be satisfied. They have to be true. So this knowledge base is false, okay? All right, so next model, okay? So false, false, true. We're looking at all the different possibilities. So what if there's no wumpus in 2.1? What if there was no wumpus in 3.2? But what if there is a wumpus in 4.1? Well, then this makes this evaluate the true, right? So the Q is true, and we know that S31 is true because we perceive the stench. So that makes the bidirectional, if and only if, that makes that true, okay? Now, what about R1? Well, false, right? Not false is true, okay? So since R1 and R2 are both satisfied, that's a true knowledge base, okay? So that is one actual possible world that we could be in, logically speaking, okay? So let's continue on. Next model, false, true, false, right? Now, this is going to be true because at least one of them is true. Now, what about our R1? That's still true also. It's true in this particular world that there's no wumpus in 2.1. Now, is R2 satisfied? Well, S31 is true. And then the Q part here, the bunch of ors is true. So, yep, true. So both of these items are satisfied. So that is a true knowledge base. Everything is logically consistent. Okay, so let's do the next possible world. Okay, so that in this case, we would have two wumpuses in adjacent squares. Okay, so this is satisfied, and we still have in this world no wumpus where we're assuming there's no wumpus in 2, 1. So that gets satisfied. Now what about the bidirectional? Is that satisfied? Yeah, because true, if and only if true is true. So this is also a true knowledge base. Okay. All right, so next model, true, false, false. Okay, so that, since we have a true for W21, that part of the bidirectional is true. Okay, now what about R1? Is that satisfied? No, it's not satisfied, which means that this knowledge base is going to be false. So we're going to disregard it when we go to evaluate whether or not the wumpus is in square 3.2. Sorry, square 3.2. Now, is the bidirectional satisfied? Well, S31 is true, and so the P part's true, the Q part's true, so this is true. But the thing is R1 is not satisfied because remember we knew that that square had no wumpus. So this particular model, M5, makes our knowledge base false, so we'll disregard it. Okay, so the next model, I mean basically anything that is going to have, or we assume that the wumpus is in 2, 1, is going to cause our model to be invalid. Right? That knowledge base for that model is going to be invalid. Because remember, we know that there's no wumpus in 2, 1. Okay, but I'll just flesh out the table really quick. Let's see here. So true, true, false, true, false, true, false. Okay, and now there's one more possibility, one more model for this world, and that's true, true, true. Right? So assume that there's a wumpus in all 3 squares. Right? That makes the Q part true. Right? This is the Q part. But again, that invalidates R1. Okay, and so the Q part's true, the P part's true because we detected this tension in 3, 1. So that makes the bidirectional true, but that invalidates our knowledge base. So that's a false knowledge base. So what are the true knowledge bases? Okay, just these models right here. Okay, just these 3. So those are the only 3 that we're going to consider. Right? These are the only possible worlds based on what we know. Right? So let's examine it. Okay, so what we want to know is, does the knowledge base entail that there's no wumpus in 3.2? Do we know that for a fact? Okay, well, if we take a look at these 3 possible worlds where the knowledge base is true, right, it holds in those worlds that there's no wumpus in 2, 1. And this is consistent with what we know because our agent passed through that square and didn't die. Okay, so now what about squares 3, 2, and 4, 1? Right? Well, in one particular model, 3, 2 has no wumpus. Yay, it's safe. Right? But in the other 2 possible worlds, in the other 2 models, there is a wumpus in that square. So they're in conflict. So we can't say for certain that there is no wumpus in 3, 2. So we can't say, it is not true, we cannot say that our knowledge base entails that there's no wumpus in 3, 2. It doesn't follow. Okay, so let me give you one more example where it will follow, where it does entail. Right? So let's say that our agent started in the start square, okay, and moved through squares 1, 2 and 1, 3 without perceiving anything. Okay, so that would mean that 1, 1 was safe, right? And it would also mean that 2, 1 was safe. It would mean that 1, 2 was safe. It would also mean that 2, 2 was safe. And then we move through 1, 3 without perceiving anything, safe, safe. And then the agent ends up moving into 1, 4. Okay, moves into 1, 4. Okay, which we knew was safe because when we were in 1, 3, we didn't perceive anything. But now in square 1, 4, we perceive a breeze. Okay, Now, the question becomes, is there going to be a pit in 2-4? Right? Now, based on the way the game works, if you perceive a breeze, there must be a pit in one of the, or both of the adjacent squares. Right? So, is there a pit in 2-4? Right? So let's say that the agent wants to decide, can I move to 2-4? So what are some rules for our knowledge base? Right? What are some things that we know? What are some sentences we can put in here? Well, the first one is that there's no pit in 1-3. Right? And we know that because we traveled through it. Okay? What's the other rule? Okay, the other rule is that we've sensed a breeze in 1-4. Okay, and if there's a breeze, then there must be a pit in at least one of the adjacent squares. So that means there would have to be a pit in 1-3, or there'd have to be a pit in 2-4. Okay, so it's time to bust out the truth table enumeration algorithm. So what are the variables here? Right? Is there a pit in 1-3, or is there a pit in 2-4? Okay, and for bookkeeping again, I'll go ahead and just put the or here. Right? So I'm not making a variable for B14 because I know that's true. I sensed it, right? So that's not going to change as I'm going through and trying to determine whether or not there's a pit in 2-4, right? So I would be writing T in that, for every row in that column. Okay, so in order for my knowledge base to be true, remember that both R1 and R2, all of your sentences that are in that knowledge base, have to be true. They have to be satisfied. Okay, so let's go through. Now, how many possibilities do I have here? I only have 4 this time, right? Because P13 is either true or false, P24 is either true or false. So in the first model, okay, M1, we'll assign false to both of those variables. That would make this or false. Okay. Now, would R1 be satisfied? Yes, because not false is true. Would R2 be satisfied? No, because true cannot imply false, right? So true for P, false for Q. Remember, this is the P part, this is the Q part. So that would be false. So this is not a valid world. That makes our knowledge base false. Okay, now what about the next model? Okay, well that would make, since we would say, well, in this model, let's assume there's no pit in 1-3, and then let's say that there's 1 in 2-4. Right, well then that would make this true. And so then the P part would be true, the Q part would be true. Okay, so R2 would be satisfied. Does that also satisfy R1? Yes, because not false is true. So this right here is a true, knowledge base. Okay, so we're going to consider that one. What about the next model? Right? Pit in 1-3 and no pit in 2-4. That would make this part true. Now, does that satisfy R1? Well, the opposite of true, right? R1 is not P13, would be false. That invalidates the knowledge base. Now, is R2 satisfied? Yeah. Right, but the knowledge base itself is false. Okay. Let's see here. So the last possibility, the last model that we could have, the last possible world that we could have would be having pits in both of them. That would certainly satisfy P13 or P24. Now, does that satisfy R1? No, because not P13 is not true, which is false. Right, now, is R2 satisfied? Yeah, because true, if and only if true, right? True, if and only if true, is true. So that is a valid, that's satisfied, but the knowledge base itself is not true. It's false. Okay, so since this is our only true knowledge base, model M2, for that possible world, that's the only one that we're going to consider when trying to decide whether or not there's a pit in 2-4. Okay, so since model M1, that knowledge base is false, it's logically inconsistent. M3, logically inconsistent. M4, logically inconsistent, right? Because in the first world, R2 wasn't satisfied. In the third, R1 wasn't satisfied. In the fourth, R1 wasn't satisfied. Only in M2 were both sentences satisfied. So that's the only one that we're going to consider. Now, let's take a look at the configuration of the truth values for the pits, right? So here, there is no pit in 1-3, right? That right there is false, right? Which holds because we know we passed through that. Now, what's the only other possible pit we have here in 2-4? And so that's true, right? So we can definitively say, based off of our algorithm here, we can say that our knowledge base entails that there is a pit in 2-4, right? Or you can say, right, if we're gonna make the question, phrase the question one way and say, well, does the knowledge base infer that or entail that there is a pit in 2-4? Well, in that case, yes, right? But does the knowledge base entail that there's no pit in 2-4? No, right? It doesn't, because we know that there is a pit, right? This is the only valid model that we have, and in that valid model, there's a pit in 2-4. Okay, anyway, so there was a couple of really quick examples for you, and I hope that that helped clear things up if the example in the previous video wasn't as clear as it could have been. As usual, you got my email address. You know when my online office hours are. You know how to get a hold of me. Feel free to ask anything, anytime. So just give me a holler if you need anything, all right?